This is a problem from section 2.2 from Openstax Precalculus. It's number 19. What we're trying to do is determine the slopes of these two lines, line 1 and L2, and then we're trying to determine whether the lines are perpendicular or parallel or neither. So let me just point out that M1, if I write M1 is equal to M2, that's if and only if L1 is parallel to L2. And if I have M1 times M2 is equal to -1, that's if and only if L1 is perpendicular to L2. The problem with what I wrote down is that looks sort of like some strange writing from an Egyptian tomb or something like that, an ancient tomb. But it's descriptive and it's short. But this is what we have. Maybe I should add on, say it's parallel. Parallel means that M1 equals M2, and perpendicular means that M1 times M2 is equal to -1. I already wrote enough, but I'll write parallel. Perpendicular. Oh, that's too much. Okay, anyway. So let's check out for M1. M1 is equal to delta y over delta x. So we're going to take the difference in the y values. So we have, actually without a calculator, it's a little bit of trouble. So 89 minus -55 divided by 10 minus -8. So this is 89 plus 55, which I believe is 144. And then we're dividing by 10 plus 8, which is 18. Well, all right. So 18 is 9 times 2. That's the easier one. But 9 goes into 144, I believe, 16 times. So that's 16 over 2, which is 8. Which now makes me see that, I suppose that, well, anyway, I think we have the right answer there. So 8 times 18 is 144, apparently. I guess I should have seen that from the start, but anyway, that's all right, I think. Okay. Now I'll go over to the other one. M2 is equal to delta y over delta x. And that'll give us -14 minus -44. And then I'll have 4 minus 9. So this is -14 plus 44 over -5. So that's 30 over -5, and that's -6. Well, it's not very exciting that they're not. Okay, so M1 is not equal to M2, so it's not parallel. And M1 times M2 is equal to 8 times -6, which is -48, which is not equal to -1. So it's not perpendicular. Well, that was too nothing. I just feel like We went to a bunch of work and didn't get a prize. Now I'm stuck trying to spell this. But you could just write not upside down t for not perpendicular. I feel like what we're going to have to do is do the next problem that's in the same problem set. To at least get one of these gives us something good here, because I feel like we just got nothing out of that except hard work. Just got blood, sweat, and tears from that one. Okay, so let's move on to another one. Let's do there's a whole bunch in this, but let's do 21. See whether anything good comes out of that. Okay, so let's check this one out. So I'm in the same directions. Find the slopes, are they parallel, perpendicular, or neither? So this one, by the way, is finally a big neither. Boo. Okay, so let's try to do M1 here. M1 is equal to delta y over delta x. So I'm going to get 5 minus 7 divided by 5 minus 1. Where I'm looking is over here. 5, and 1, 7. So that's going to give us 5 minus 7 is negative 2. 5 minus 1 is 4, so that's negative 1/2. M2 is equal to delta y over delta x. So this will give us the difference in the y coordinates divided by the difference in the x coordinates. It's too dark to see. So I have that purplish thing there. Okay, so I have 1 minus negative 3, which is equal to 4, and then 1 minus negative 1, which is equal to 2, and that's 2. What? Looks like something's coming together. I see that negative 1/2 and 2 are negative reciprocals of each other. M1 times M2 is equal to negative 1/2 times 2, which is equal to negative 1. Therefore, I'm going to use these arrows, the double arrow. It's not just one arrow, it's double arrow, which means therefore, and that I'm going to say therefore L1 is perpendicular to L2. Oh man, how satisfying is that? We got one where we got something good. I feel like I really achieved something. That all that work paid off. Okay, well, is that silly? I think it is, but I still feel that way, that something good came out of that. Let's try number 23, same directions. We're going to find the slope and then decide whether they're parallel or perpendicular. Okay, let me back out a little bit from that. And I'm using the same idea. If M1 equals M2, they're parallel. If M1 times M2 is equal to negative 1, they're perpendicular. And if none of those happen, then they're neither. So those are if and only if statements. The double arrow that I'm showing right here means if and only if. Okay. All right. Now let's check it out. Let's do the next one. See what happens. So I have that M1 is equal to, again, rise over run, so it's delta y over delta x. And so I'm going to take the difference in the y's, and I'm going to take the difference of the x's and find a fraction of those. So I have negative 1 minus 5, which is negative 6. I have 5 minus 2, which is 3. Divide negative 2. Well, okay. Now I move on to the next pair of lines. 3, negative 5, and negative 3, 7. negative 5 minus 7. 3 minus negative 3. Things are getting exciting here. Negative 12 over 3 plus 3, and that's negative 12 over 6, which is also negative 2. So what's the conclusion? Well, I have m1 is equal to m2. Therefore, I'll put the double arrow type thing. Therefore, L1 is parallel to L2. So I'll write parallel. Parallel. Alrighty. All right. So that was good. We did all three. We had 3 different examples. Parallel, well, we found the slope. The slopes are equal, therefore they're parallel. The previous one, the product of the slope is negative 1. That means they're negative reciprocals of each other. That was perpendicular. The first one, oh man, that was disappointing. Number 19, the slopes were not equal, and the product was not negative 1. It was neither. It's like I didn't like that one. But I guess I had to do it to see all the different possibilities. Not equal, not product negative 1 for the slopes, neither. Product negative 1 or negative reciprocals, perpendicular. Slopes are equal, parallel. Okay, for one last screenshot, zoom all the way out, make it sort of small. It's from Openstax problems 19, 21, and 23.